So my name is Siddharta. I'm from India, and I run this site, playfulpython.com, where I blog about Python topics. I'm also the author of this book, Test-Driven Python Development, which I wrote a few years back. I've been using Python for a long time, since 2002. And one of the nice features that I like about Python is that it allows us to write really compact, nice code. Right? So a perfect example is list comprehension. Right? We can do the same thing in for loop, but we can also use list comprehension and do it in a nice way. Right? So I was very initially when Python 3.10 came out. Right? That's when they announced this match statement. So now it is 3 years. 3.10 came out 3 years back. Now 3.13 is going to come. Put your hand up. How many of you have used this feature in Python? Right? So about 1/3. And what do you all think? Do you like it or no? Okay, 1 like, 2 likes. Yeah. So this is a very controversial feature, actually. So some of the people like it. Some of the people said, you're making Python so complicated. It used to be such a simple language, and now this feature is so complicated. And people can just use if-else statement. Why do you want to use match? Right? And a lot of the objection comes from not understanding what is match. And I was also in that camp. Initially, I did not like match at all. It's like, what is this, right? And when I went to search about match statement, then you get a result like this, right? You'll learn how to use Python to create a switch case statement. Right? So switch case is there in other languages, which is like an if-else, right? And so I thought, okay. If we already have if-else, what's the big deal? Why you need to add such a feature, and everyone is saying it's so complicated, just to do if-else, right? And I didn't like it. Python is such a beautiful, simple language, and now it's becoming such a mess with these kind of features. Right? So in the beginning, I was also in that camp, like, yeah, I don't like match. Right? I still don't like that walrus, by the way. Yeah. So, but I changed my mind on match. Right? So what happened? Right? And this is the kind of example. So how many of you have never seen match? This is an example. So what you do is you say match and give the variable on top. So here direction. And you can give various cases. Right? So if direction is north, then it will execute that. It will return x, y plus 1. If the direction is south, then so it goes through all those from top to bottom. And if nothing is matching, then it will come here and run the code. Right? This is when you go to Google and all, you'll see example like this. It's like an if-else, right? And I thought, okay, I can do this if direction equal to north, if direction equal to south. I can do the same thing. Why do I need match, right? So then when I went back after some time, like many months afterwards, I went back and I saw this thing here, structural pattern matching. Right? So actually, if you look at the PEP, they don't say match is like switch case, right? They call it structural pattern matching. So I thought, okay, what is this structural pattern matching, right? And then I started investigating it some more. And then only I understood, okay, what is match, right? It's not like if-else. It's not like switch case. It's something completely different. In that example, it is similar to if-else. That's it. Right? So what I'm going to do in this talk is we'll explain a little bit about this structural pattern matching. We'll see, okay, how it works. And this is one place. Normally, Python has very good documentation. I really like it. But this feature, they really did not do a good job. If you look at the documentation for structural pattern matching, you'll see all the examples are, this is really useful if you're writing a compiler. How many of you here are writing a compiler? 1, 2. Yeah, so most of us are not writing compilers, right? Abstract syntax trees. So then what's the use of this? To put a whole feature for the compiler writers, right? But actually, there are many useful scenarios which all of us can use, this feature, right? But they don't explain that properly in the documentation. That's why it's missed out a lot of people. So we'll see some of those examples where we can use match in like normal programming, right? Okay, so let's think about structural pattern matching first. Okay, before that, let's just quickly do one small detour into regular expressions. So all of you know regular expressions? Yeah? What is it for? What do you use it for? Matching strings, right? So you have some string, you have some pattern, right? And you want to check if that string, the characters are matching that pattern, right? And you have a language for that, like a regular expression language. So if I want to match this, I can say it's a word, and then there's an @ and a dot, starting of string. You have a syntax for it, right? So that describes the pattern. And then I can check whether the string matches that pattern. But regular expression also has another feature where I can extract parts of the pattern, right? So here I put the bracket, and then later on I can get that value. So if I run this code, it'll take just the SID part, whatever's in the matching in that bracket, and take it out. And then I can do some calculation with it. Right? So there are two concepts here. One is matching the pattern. Does the input match the pattern or not? And secondly is capturing some part of the pattern which we want, we can capture it out, right? So these are the two important concepts in regular expression. Okay, so just remember those two, right? So let's go to some code. Okay, here I have a code, right? Is this all readable in the back? Yeah, okay. So here I have a code where it's just a simulation, right? Doesn't actually do a request. But if it calls GitHub API. And if it returns a success, it returns a tuple right here, where it returns OK, comma, and it extracts the ID field from the response. And if it's a failure, it returns another tuple, error, comma, and it returns, second one is different, right? It returns the status code. Now, I'm going to call this function here, right? And now, how do I process this return, right? Because when it's a success, then the second field has the ID. When it's a error, the second field has the error, right? So I need to get the value. I need to check if the first value is OK. So we have an if-then like this. What do you think about this code? Do you like it? Imagine that we can't see the get user ID. It's in some other file somewhere. I'm just reading the code. It's like this, right? It's not clear, right? What is value of 0? Is that the error, true, false? What is value of 1? We don't know, right? It's not clear. I have to go to that code and see what is it returning in this first position, second position, all that, right? Now, we can make this a little better. Okay, we can make it a little better like this. So here, in this line, instead of just taking value, I'm using Python's unpacking syntax, right? I'm getting a tuple of 2 values. This syntax will automatically put the first one in status, second one in value. So at least now we know that, okay, it's returning as a status, comma, value, right? And then it's much better. But still, in the success case, the value will have a ID. In the failure case, the value will have an error code, right? It's different, right? And that is also still not clear here, right? So if I want to really make this readable, I have to do something like this. Okay, now, so you might think, what's the use of assigning the variables like this? Just for readability. Someone reads this code, at least they know what that thing is, without going to the other function, right? Now this is readable code, and Python is all about readable code, right? But now look at it. It's not so clean, right? It's kind of ugly, and it's taken so many lines to do it, right? Now let's see what we do with the match statement. Okay, here's the same code with match, right? So how does match work? Match doesn't work by matching just a value. You give it a pattern. So like regular expression, you give it a pattern. But regular expression, you give a pattern of the string. Here, you give the pattern of the structure. Okay, so here in the first match, I'm saying, here we are calling the function and getting the return value, right, in this line. And in the first case, I'm saying, if the value is a tuple, okay, and the first element of the tuple is okay, it's a string, okay, and the second element can be something else. Okay, so now I'm giving a pattern. If my data is in this pattern, okay, then execute that code. So if it's a tuple, okay, comma ID, execute that code. Now what about that ID? That ID is the capture. Okay, so remember regular expressions, we can give a pattern. If it matches the pattern, we can capture part of it and use it later on. So same thing here. We give a pattern. It's a tuple. First element is okay. Second element is something else. So only 2 elements in the tuple. And then if it is matching that, take the second element and put it in the variable ID. Okay, that's what we are saying. And then next line we can use that variable ID. Okay, so your ID is ID. Right, so it's very simple now. Right? What do you think? Do you like this one? Right? Okay, and same way for the error. Now, if the first element is error, then the second one will go into the error code variable, and we can use it. Right? So that's the idea of pattern matching. And why it's called structural pattern matching. It's matching the structure of the data. We're saying, oh, this is a tuple, and it should have this element here and this element here. If it is matching this pattern, then do it. So like string pattern matching, you have regular expression. So structural pattern matching, you have the match case. Right? So this makes it very easy to write this kind of code where the structure can change. Right? In one case, I have a different structure. In another case, I have a different structure. Right? And then I want to do something based upon that. Then you use this. Right? Okay. So this is a simple example where we just have a tuple. Now let's look at another example. Right? Yeah. Okay, APIs. Right? Many times we work with API, and API returns back some JSON usually. One of the things about APIs is often the structure will be different. Sometimes some fields will be there, sometimes some fields will be missing. Right? Sometimes the entire structure itself will be different. So here's an example of an API. Right? This is a GraphQL API. Okay, it doesn't matter, but what matters is this is the structure of a success. So if I do the API call and it's a success, I might get a response something like this, data, and inside that something, whatever I requested. Right? But if there's an error, right, in GraphQL, it will validate everything. If there's an error, the response will be like that, JSON. So in that, there's no data, there's errors. Right? So when I do response and get the JSON, the data may be like this. I might have dictionaries and lists. Or the data may be like that with some dictionary with some other keys and some other list. Right? Now I have to process this. Now how to process this? Right? Normally, if I have to process this, I need to check, is the errors key there in my dictionary? Right? If the errors key is there, that means it's an error. So then I have to check inside the error. I have to loop, get all the messages, and process all the messages. Right? But if the error key is not there in the data, then it's a success. Right? Then I have to check, is the data key there? If the data key also is not there, something has gone wrong. Right? Then I need to handle that case. Maybe the data key didn't come. Right? So I need to check that. And then I might be interested in, something here, or maybe these IDs or something. Right? Then I need to check, is there a hero inside that? Because any field could be missing. I might get a data, it might be an empty dictionary, right? So I cannot just directly access whatever I want. So I need to check, is there hero key? Inside the hero key, is there that hero friends, right? And inside that, so we need to check each and everything, or we need to catch exceptions, try except key error, try except index error, all those things, right? Now, if I want to process this with GraphQL, right, let's take a look. Right, so here's an example. Right, so here we just give the pattern. Here we are giving a dictionary pattern, right? Previous example we give a tuple pattern. Here we are giving a dict pattern. We are saying, is it a dictionary? It is having the key errors, colon. If it is matching that pattern, then whatever is the value of that key, capture it in the variable errors, right? And then I can loop for error and errors, do whatever I want to do with the errors, right? Or if it does not match that pattern, right, I can check, is it having it's a dictionary, it's having a data key, and inside that value is another dictionary having the hero friends key, then that value, capture it into the variable friends, right? And then it also allows us to add a condition. So, in list comprehension, right, we can say for this, and then in the end we can put a condition, right? If a %2 is equal to 0, right? We can give a condition at the end. So we can do the same here. So I can put a condition if none is not in friends. So if it captures all the friends, and then if any of them, all of them, none of it is none, right? Then it will succeed, it will process it. But if that condition is failed, if none not in friends, if that condition is failed, it will skip that. And it will go to the next one. So data, hero, name, capture that, and then print it. Right? So you can see how simple this code is. Right? It's 3 lines, 3 cases, each one is 2 lines. You can easily see exactly what is the pattern, what do you want to do. What's the pattern, what do you want to do. Same thing you can't do with if-else, because you have to check all the intermediate steps. Right? Any of those things may be missing, it may be none, right? Otherwise, try, except, you have to put it everywhere, right? But here, it makes it very clean, very Pythonic code, actually. Right. All right. So this thing here is called a guard. You can put it here. So let's just run this code. Okay, so this is the success scenario, right? So it ran it got the list of friends. None of it is none. So it has gone and printed each of the friends from that success response. Okay, so now I'm putting a none in the middle of the response. Okay. Okay, because I put a none, so now this case does not match anymore, right? So what it does is it captures the friends. Okay, after capturing the friends, then you can put further conditions in Python code like that on the value of that captured value, right? And it goes top to bottom. So first this failed, then it comes to this pattern. Because of that if none not in friends, this condition also fails, right? Then it comes here, and then this condition passes, and it goes and executes that line, Right? So this is another very common example. All of us work with APIs. APIs often have like this different structures. Right? Match is really amazing for that. Okay, another example. All right. So here we see how match can be used with custom classes. So the previous one was with dictionaries. You can use with list and tuples. Here we are using match on our custom class. So I have a point data class over there. Okay, and I'm matching on the value. So I created point is 0, 10, 0. And here we can match on specific values. So if it is 0.000, we can do something. If it is 0.0, anything, 0, right? And same way for all the others. And if nothing matches, we capture all the 3 variables. So x, y, z, we capture all 3 and process it, right? So here, if we run this, yeah, so it's 10 units on the y-axis. If I make it 0, 0, 0, right, then it's on the origin. So you can also capture like this. You can extend this to even pattern match among custom classes, right? You create your own class, there's an extension, right? And you can get more complicated. I'm not going to go into all the things what you can do with pattern matching, but just to give an idea of like how this works, right? And where you can use it. So you can say, in your case, you can say this or that, right, by using a pipe. So point of 0, x, y, like if I do something like this, yeah, so if I do like this, if it's this or that, right, then it will match. So you can give conditions like this. You can actually do very complicated. Just like regular expressions, you can do simple ones. You can also do very, very complicated regular expressions. Same way here, you can give very complicated patterns. But most of the time, you don't need to do very complicated patterns, right? Simple ones will work. Okay, so this is an example where we are working with different types of a single class, but with different values. You want to handle different values in different ways. Right, now another one. Okay, here I've got 2 different classes. So imagine you're a bookstore, right? In your bookstore, you've got books and you've got video games, right? You're like Amazon, right? So you've got books, video games. Books have got different fields and video games have got different fields. So you've got 2 different classes, one to represent books, one to represent video games, right? Now you have a shopping cart. In the shopping cart, you may be having books or video games or mixture of both. Right? You want to go through each item and process them one by one. Normally, what we would do is you have to check the class. Is instance of something, right? You have to put a condition like that. But with pattern matching, it becomes really simple. So you can say match item, and case book. So if it's a book, it'll match that, and then you can capture the fields, whatever fields you want. Name, author. We can use underscore when we don't care about that field, right? So here I'm saying I want to just capture the name and author from the book. If it's a video game, then capture the name and the platform and ignore the publisher, right? So here again, we use match case. In one line, we just specify the pattern, right? And match it, capture whatever fields we want, and then process it. Right? You don't need to check if is instance. If it's book, then find book dot publisher, book dot whatever it is, name, author. Right? So here we can. So the cool thing about pattern matching is we can match the pattern and capture the pattern in one go. Right? Then there are also other examples where pattern matching just makes a simpler way of if-else. So these are all examples where in if-else it becomes very ugly code, right? But you can also use pattern matching as well, like a normal if-else, like that first example which I showed. Right? There you can use if-else, no problem, or you can use pattern matching. Personally, where I like to use pattern matching, right? A lot of people say, why not just use if-else, right? And my response is, when you take list comprehension. Right? How many of you like list comprehension? Can you raise your hand? Lots, right? Almost everyone likes list comprehension. But you can do the same thing with for loop, right? So why do you want list comprehension? Is it making the language complicated? No. It's how many of you like for loop? Raise your hand. Right? You can do that with a while loop. Right? So do you want a for loop? Right? So the thing about languages is especially when you want it to be readable. You can do everything with assembly language, right? But when you want something to be readable, it has to convey the intent, what you're trying to do, right? With a for loop, you're conveying the intent that I'm processing items one by one, right? With a while loop, I can do anything. I can go front, back, skip items, do everything, right? But with a for loop, the intent is that I'm going through a sequence one by one. And with list comprehension, the intent is I'm building a list, right? A lot of people think list comprehension is another way to write a for loop. Actually, a list comprehension is another way to write a literal list, right? Instead of giving square brackets 1, 2, 3, where I specify all the values one by one, it's a way to create a list using a formula, right? It's not a way to do a for loop. Internally, it does a for loop. Right? So same way here, where would I use match? Where would I use if statement? Right? I like to use match where I am checking for structure. Right? So if I want to check whether a list is empty, right? I can do if len of list is equal to 0. Right? That checks whether the list is empty. Or I can say match open brackets, close brackets. Okay, match case, open bracket, close bracket, also matches if it's an empty list, right? So when I'm matching structure, I like to use match statement. I don't want to say if len, you can, but this conveys the intent that I'm trying to match a structure, right? So in those cases, I think, right, match is really good. Now there are more complex cases, right? Here I've just given a few simple cases. You can make complex patterns, and I think there was a talk on functional programming also yesterday, right? In functional programming, this is used a lot, right? Because there's a lot of, in functional programming, they don't use exceptions and other things. Match gets used a lot because a lot of things are done using structure, even normal things. So those are advanced things which now you can do in Python in a very simple way. If you want to write functional programming style in Python, this is really useful. But even if you don't want to do that, right, all these use cases which I've given, any normal programming, you can just put match there. It'll make your code better. Right? Okay, cool. So let's just summarize. Okay, before we summarize, let me take one final. example gone? Okay, never mind. Here's a code. What do you think should be the output? If we give it some x, y, and direction. Any guesses? So based on the direction, it will do the calculation and return. Right? So if we look at the linter, right? You run MyPy or in your IDE, it gives this next to the code. Okay, it's giving so many errors. Firstly, it says north is not accessed. What does that mean? Right? Don't understand that error. Then it says same thing for south, east, west. And then here it says code is unreachable. Right? So something has gone wrong, but the error is not really clear. Right? So here's the important thing with match. When you have a case, whatever is inside is not a Python code. It is a pattern syntax. Okay? And in the pattern syntax, when you put a variable there, it is used for capturing a value. Okay, so when you do case north, what that means is any value, capture it into a variable called north. Right? And then I can use that variable inside. All right? And I'm not using that variable, that's why it's saying north is not accessed. All right? So this doesn't mean match it with that variable north, that string over there. It doesn't mean match it with that string over there. Right? It means, and this, there's no pattern here. So no matter what is my data, that first case will always match. And whatever is the value will be captured into a variable called north. Right? And so it can never come into any of these. That's why it gives this error, code is unreachable. Right? So we need to be a little careful here, because whatever is here is not a Python code. It's not that it's going to use that variable and match it with that. Right? It has its own syntax. That's the one thing we have to be a little careful about. Right? In fact, there's a way to get around this. We can put it into an enum or something like that. So now this is not a valid variable name, right? So it cannot be used for capture. It doesn't match the capture syntax. So now if we do it like this, the code will work as normal. So that's the only thing to remember. Whatever is here is a special syntax. It's a pattern. Just like regex has a pattern matching syntax, this also has a pattern matching syntax. Right. All right, cool. So yeah, so one final thing, right? Many times, let's go back to this code. Like this. Here we returned a tuple, right? First we returned with OK, second time we returned a different kind of tuple. Now normally in Python programming, we don't often return different structures, right? Because it's very difficult to process. When I don't know if my return value is going to be a tuple of 2 items or 3 items or 4 items. Then we have to put all those if-else check. If it has 2 items, if it has 3 items, it's complex, right? So normally what happens is we try not to return or create such a function because we cannot process it easily. Now with match statement, it becomes easy to process different structure, right? Which means it also becomes easy to write functions which return different structures. That till now we never used to do it. Now we can do it because we can easily process such functions. Right? So it also changes our behavior, how we write our original functions. Right? So that's what we have here in the final thoughts. Right? Recognize the situations where it shines and use it. You don't want to use regex to check if it is north, south, east, or west. Right? So same way, you don't need to use match for everything. Right? But as you design the system better, the match statement becomes more useful. Right? So you start creating these functions which return different structures. Or you start processing APIs which are in different structures. So then the match becomes really, really useful. Right? Which is something we avoided till now. All right, cool. So we can take questions. How much time do we have?
Thank you very much. I will definitely start using this statement myself. So there are some questions. People are asking, Lorenzo is asking, what IDE are you using that you showed?
Oh, that's NeoVim.
Okay, thank you. And is there a benefit in performance in using the match statements versus if else?
I'm not sure about that, right? There is, yeah.
When it converts it to bytecode, there are less operations that are required in the match statements. Yeah.
Awesome. So it is more performant. But the main thing for me is the readability, right?
And Marco is asking, do you need a data class to pattern match a custom object, or can you avoid the data class?
You can, yeah, you can do it even with normal classes. It doesn't have to be a data class. There's a _ match _args. There's a field like that which you can use to match with any class, your own classes. Right? But it works well with data classes where you're storing different types or different structures of data. It's a good fit, but you can use it with any kind of class.
And Rodrigo is asking, you showed that or Boolean operator is working, do other operators are also working, like the ampersand and the tilde?
So OR is for matching this or that, right? It cannot match two patterns, right? This and that. So I think only OR is there, right? So it's this or this or this. And you can put that guard if those are the two options which are available.
Okay, are there any more questions live?
Yeah, thanks a lot. I was wondering about what is actually matched. You kind of mentioned right now a double under method, like double under match, which is, I guess is
rags, yeah.
Okay. So that is called when we try to match something. So I guess if we are trying to match like a complex a class with a heavy instantiation, that's probably a bad idea, right? Because
complex class which has
something that has a very heavy constructor and takes 5 minutes to create an instance of. So that's probably a bad idea because it's not we are not matching a string. We're actually matching a data. So we're building the data structure that we're matching there.
No, so that is just the pattern, right? It just tells what is the pattern. So it doesn't actually create, when we match like point of 0, 0, 0, it doesn't create a point object and match it, right? It just says that it should be a point class with the x value 0, y value 0, z value 0, right? So that is just a syntax for telling what is the pattern what we want to match.
Okay.
Okay, but that's not a Python code. It doesn't run that and create a point object and then compare the two objects. It doesn't do it that way.
Okay, and so I didn't know about double under match. So that method is a class method, I guess.
Yeah.
Okay. Okay.
So that tells you like what are the fields which need to be matched.
I see.
Right, and then in your pattern you can match those fields, whatever you specify there.
And what is the flexibility? Because, for instance, you showed an example with a two-tuple. Mm-hmm. Could we do the same if we pass to the matcher a list of 2 elements? Does it match if it's a list with 2 elements instead of a tuple of 2 elements, for instance?
No, that won't match.
So it must be the same structure.
It must be the same.
Okay, thank you.
Has this question, but I didn't. You asked probably this.
No, that's not me.
Okay, so we had this question online. Okay, so there's one more question. It says like this, in the first example, ID is not only a valid variable name, but also a Python inbuilt. Is it theoretically possible to match ID or the string function or others?
Yeah, so it will match. The ID will get that variable, but it's like shadowing the function name, right? So inside that block, like ID will be that variable. It's like you can, in Python, you can say ID is equal to 0. It will work, right? But then you can't use the original function. So yeah, it will work. It shadows the ID actual built-in function over there.
Any more questions live?
Yeah, good talk. In the second example, I think you showed a nested objects structure. I was wondering if you know any pattern that could match a list of objects, or we will need to traverse a list of objects and then do the matching.
So a list of objects meaning?
Yeah, like a list of dictionaries.
Okay. So like what is here?
Yeah, that's basically a nested object. So
Yeah.
I was wondering if there is any pattern that you know, which is a list of different dictionaries. I'm just thinking of APIs.
So you can match a list if it has a fixed number, like a list containing a dictionary, comma, dictionary, comma, dictionary. You can match that way. But you cannot match list with any number. There's no pattern. Yeah. Can't
you use the split for this, maybe?
The star? Star is used for the capture. Right? So if you want to capture everything into the variable, you can use the star. Right? So if I give a list of star variable, it will capture the entire list into the variable.
Yeah, but maybe you can do like A, comma B, comma star tail. I don't know. To capture the first two ends.
Yeah, for the capture, you can do that, but not for matching. I think the question was, can we match the type of dictionaries, right?
Yeah, like all the objects in the
List have to be a dictionary.
or the same.
Yeah.
Or containing, for example, hero friends.
Yeah, that way you can't.
Okay. So
Yeah.
no, that's fine.
So what's that something? Any more questions? Then thank you.
Cool.
That would be all. Thank you very much.
You.